Hey students, I have some good news and some bad news. The bad news is that I forgot my stuff in the classroom over the weekend, so I did not get a chance to record a video on my iPad. But the good news is my husband had his laptop at home, so I was able to record one on his computer. What that means is that this video is going to look a little bit different than some of the videos we've had before because I'm going to be talking and all you're going to see is a computer screen instead of me like writing on the iPad. So hang in there with it, and thanks for being such awesome students. Okay, bye. Okay, so here's your definition of rate of change. It is a ratio of two changing units, usually simplified to a unit rate. So notice what we're bringing in here is a bunch of things from the past. Ratio, right? That's an old word. That means we're comparing two quantities. And we're bringing also in here unit rate. A unit rate was a ratio of two different units, but notice the difference here in this definition of rate of change to changing units. So a unit rate is something that we didn't really look at a graph, we didn't look at a table necessarily to find it, but a rate of change, we're probably going to look at a graph or a table or some sort of data to help us figure out what's changing, and both of them are going to be changing. Okay, and then we would simplify it then to a unit rate. Okay, so once you get that written down, you can move on in the video. Okay, so the first thing we need to talk about before we get into any specific problems is, remember how we talked about unit rates and how we had one unit in the numerator and one unit in the denominator? Well, when we rewrote our unit rates, it was always something per something. And anything that was after the per, like here it says students per year, anything that was after the per was in the denominator. So when we look at this rate, students per year, the year is right here. The horizontal axis is going to be in your denominator every time you're looking at a line graph, okay? And then also the students then is going to be in the numerator, okay? So if you want to go ahead and draw in your notes two axes like this, a vertical axis and a horizontal axis, and then along your vertical axis write numerator to remind yourself that that's what goes in the numerator, is the change that happens there. And then along your horizontal axis, write denominator, so you know that's the unit that goes in the denominator, okay? So numerator is vertical, denominator is horizontal. If you're in a table, you need to use, again, per year. The year is going to go in the denominator, so the left side is going to go in the denominator, and the right side is going to go in the numerator. So denominator actually comes first, which is kind of weird, but the denominator's over here and the numerator's over here. Okay, so let's talk about this first question. This question says, a school administrator who was concerned about grade inflation looked over the number of straight A students from year to year. According to the graph, what was the rate of change between 2012 and 2013? So we want to look. We're going to go here to this graph, 2012, 2013. We want to see what kind of change happened. Well, if we go over here to read the number of students, we see that in 2012 they had 25 students, and in 2013 they had 25 students. Well, what changed? Nothing. Still have 25 students. So for this question, the answer would be 0 students per year. 0 students would be in the numerator. 1 year would be in the denominator, but 0 divided by 1 is 0. So that's just going to be 0. Okay, next question. Each year, the Georgetown School District publishes its annual budget, which includes information on the sports programs per student spending. So according to this graph, here's the question. What was the rate of change between 2009 and 2010? So let's go over to 2009. We see there's $27 there. And 2010, there's $34 there. So if we're looking for the rate of change, we're really asking what's the difference? Remember, difference has to do with subtraction. What's the difference between money here and money there? So remember how I talked about unit rates, rates of change. We're going to use ratios. So we're going to do some fractions. Our first fraction, we're going to set this up 34 minus 27. We're going to start with where we ended. So this is where we ended up. We ended up with 34 and then go to where we started. So take the 2010 number and subtract the 2009 number. 34 minus 27, and that happened in 1 year, right? 2010 minus 2009 if you want to do that. Okay, so when we actually work out that math, 34 minus 27 is $7 and still 1 year. And then if you wanted to rewrite it, it would be $7 per year. Again, if you put it in down here, the 7 would go in here and then per year. All right, now we're moving on to tables. This question said Owen kept track of how long it took to finish his homework each day. According to the table, what was the rate of change between Thursday and Friday? So we're going to look at these numbers, Thursday and Friday. Now remember, we said we're going to take the new number, the second number, and subtract the first number because we're looking for the difference. So Friday's number minus Thursday's number, and that's going to go in the numerator, right? So we're going to take Friday's number and subtract Thursday's number. Now this is kind of weird because we're taking a smaller number and subtracting a bigger number. What ends up happening, though, is that you can tell that the rate of change is 7. From 40 to 33, that's a difference of 7. But because it went down from Thursday to Friday, from 40 to 33, we're going to say that's a difference of -7. So it's -7 minutes per day is what you would need to write for that one. If you have questions on negatives, we will talk about them more in class tomorrow, so please write down any questions you have, and I will make sure that I address them. All right, and then the next question. To figure out how many vacation days she had left to use, Olivia looked over her old calendars to figure out how many days of vacation she had taken each year. According to the table, what was the rate of change between 2014 and 2016? So this one we actually have multiple years we're talking about, not just 1 year. So we're going to look at the 2014 number, 20, and the 2016 number, 24. And again, we're going to use the same thing. We're going to do the subtraction. We're going to take the 2016 number and subtract the 2014 number. So 24 minus 20, and then in the denominator, 2016 minus 2014. I mean, that's easy. You can do that in your head. That's 2 years, but we're still going to write it in our fraction. Okay, so here it is, 24 minus 20 days, and 2016 minus 2014. Then we can simplify. 24 minus 20 is 4 days. 2016 minus 2014 is 2 years. As we continue to simplify, 4 days can simplify to 2 days if 2 years simplifies to 1 year, right? 4 over 2 is the same as 2 over 1. So now we have turned this into, if we have a 1 on the bottom, a unit rate. Remember, a unit rate is one that has a rate that has a 1 on the bottom in the denominator. All right, then finally we can rewrite this 2 days per 1 year as 2 days per year, and that would be our answer for this problem. All right, next problem. A vendor who sold bread at farmers markets counted the number of leftover loaves at the end of each day. Question, according to the table, what was the rate of change between Wednesday and Friday? So this time we're going to look at Wednesday's numbers, Friday's numbers. Notice again, this has gone down. 37 to 33 is a drop. So when we write this, we're still going to write Friday's number first, even though the Wednesday number is bigger. We're going to write this as 33 minus 37 loaves, and Wednesday to Friday is 2 days. Now you can go ahead and enter this into your calculator if you want, but when you take a smaller number and you subtract a number that's bigger, you're going to end up with a negative number, right? So we have 33 minus 37 gives us -4, which basically just means that the vendor sold 4 fewer loaves on Friday than he did on Wednesday. So this is 4 fewer loaves, that's what the negative represents, over the 2-day span, okay? This stays 2 days here in the denominator. All right, and then again, we simplify 4 loaves over 2 days. A fall of 4 loaves over 2 days is the same as a fall of 2 loaves every day. Now this might be a little confusing because you look at this, that doesn't fall 2 loaves. That actually goes up 6 loaves. And then that falls 10 loaves. When we talk about the rate of change, we're not saying that this is the way it happens every day over the span that we're covering. So we're not saying Wednesday to Thursday it fell 2 loaves and then Thursday to Friday it fell 2 loaves. When we're looking for a rate of change, we're just saying to get from Wednesday to Friday, at what rate would it needed to have changed? So if it did 4 loaves in 2 days, that's an average of 2 loaves a day, okay? It's not saying that it actually did that, it's just saying that's what the average rate would be, okay? So then we can end this problem by saying -2 loaves per day. We would write -2 in this blank right here. All right, this is the last problem, and then you're done with this video. Fans of the Greenwood baseball team compared the number of games won by their team each year. According to the table, what was the rate of change between 2005 and 2008? Now this is, again, over a span of a couple of years, so we got to make sure we enter this correctly in our ratios. So we look at our 2005 number, 25, our 2008 number, 19. Notice again, it's falling, so we're going to be dealing with negatives. When we set this up, we're going to start with our 2008 number, 19, and subtract our 2005 number. Just like down here, we said 2008 minus 2005, okay? So 19 minus 25 games, and 2008 minus 2005. Okay, again, you can put this into your calculator if that helps you, but 19 minus 25, what that tells us is it went down 6 games total in 3 years. Okay, so -6 games over 3 years. Again, we can simplify this fraction. A fall of 6 games in 3 years is the same as a fall of 2 games per year. Now again, same as last problem. This is not saying it fell 2 games every year. This is saying in order for it to have fallen 6 games in 3 years, that's an average of 2 games per year, okay? That's not necessarily what it did. That's the average of how it changed over that time span, okay? So then we would rewrite it as -2. We keep this -2 games per year.